And so I've got the function 1/2 x squared plus x minus 3. And looking at your work, just one little tiny mistake, but everything else looks pretty darn good. So I don't know where the error came from. The error may have come from the graph. So, but we'll take a look at that. So anyway, you go ahead.
Sorry.
Go ahead.
I have been having a lot of stress and resistance from MathXL itself as a program. I personally don't like it. So I feel like that's what's really messing me up.
I see your error. You have a vertical transformation of 7/2. It should be minus 7/2.
Okay.
So I'm looking at that picture you sent me. So, but it's okay. Let's just do it. Okay. But your algebra looks good. You took out a half from the first two terms. You kind of cheated that piece a little bit. You wrote just an x here at the beginning, but that's okay. You want to make sure you can cheat it, but then put in what should be there to fix it, right? Don't keep an error on the page. So again, what am I going to do as a student? I'm going to make sure I distribute back and see that I get back to the original, right? So after you factor that out, distribute back. Factoring out a 1/2 is not that difficult. It's easy to see when you distribute it, the 2's cancel. So then you just have to remember, if you factor out a 1/2, you need a 2 in the numerator. Now I find k. K is 2. 1/2 of k is 1. And 1/2 of k quantity squared is also 1.
Are you sharing your screen?
Oh, sorry. Thank you. Silly Robert. So we're trying to show that this is a transformation of the mother function, right? And so I factor out the 1/2 from the first two terms. And again, I'm distributing back to double check it. Okay, it worked. And then I find k is 2. 1/2 of k is 1. 1/2 of k quantity squared is 1. I'm going to add that 1 inside, which means I've actually added a 1/2, and I'm going to subtract it on the outside, get rid of it. And you did that perfectly. So that piece, right, that piece that I have now in the parenthesis always turns out to be x plus 1/2 of k quantity squared. And then I got a common denominator there, and I got 7/2. So this is now my vertex form, right? And I can see certainly that I've got a transformation of x squared, right? And so my vertex is at -1, -7/2. Remember, I'm going to do the opposite of the x and keep the y. And I believe that's where your issue is. So you did the opposite. You kept the x and you switched the y. That's all.
Oh, I see.
Oh, no. And then you didn't get your vertical stretch. Oh, you're confusing the words, that's all. So the vertical stretch is a 1/2. Vertical stretch is a 1/2. Horizontal stretch, none. And there won't be until we do the trig. Vertical shift, that's up or down, is -7/2. And horizontal shift is -1. So you just had some things mixed up. So what? Your algebra was good. So, but otherwise, it's
when I'm doing it on MathXL, like I see that my algebra is right, but it's not plugging in right, so I get frustrated.
That's fine, but this is what I want to see on the paper as well, right? We have for x squared, we have our 1x1 box, right? So there's y equals x squared. When I put a y equals 1/2, right, I should get half of the height of my box. Y equals 1/2 x squared now. And so there it is now. So you can see here I had the point 0011, right? And when I do that compression in the y direction, that means take that 1x1 box and make it a height of a half now. And now I want to move it, right? -1 to the left. So there's my box now. So here is now y equals 1/2 x minus 1 quantity squared, right? And then finally, I want to take that whole thing and move it down 3.5, right? So there's 1, 2, 3. I'm going to move that 1/2 by 1 box down 3.5. So there's 1, 2, 3.5. There's my new box. There's my new function. So I'm expecting you to see all of this on your paper.
Is that 3.5 or 7?
7/2 is 3.5, right?
Oh.
So I'm right. I taught you that little 1x1 box piece of the mother functions because if you manipulate that box, then you automatically know where your radical's going through or your quadratic's going through. And then once you get that, and remember you're doing this on your calculator too, right? So Cindy, when you're doing this on
I use my calculator too.
Right. So you gotta. It's almost like you gotta kick it a couple of times until you figure out what the hell's going on with it. But I certainly am happy to. If you want to stay right after class, I can make sure you see how you manipulate those things and see how they move. Okay.
Okay, thank you.
Yes, and I don't like MathXL either. I don't like any of the programs. If we were face to face, our class was face to face, I wouldn't use the program at all. Everything would be out of the book and you'd turn it in to me. I think teachers are a little lazy. They don't want to grade homework or look at homework, so I don't know. I don't get it. Nice, Isaiah. I got your problems. Thank you. Oh, by the way, the spring classes are out, and so let me just share with you real quick. Spring Calc 1 classes are out, and there's a heck of a lot of them, which is awesome. So I like just to go to the regular Montgomery College site, right, the main website, and I can just hit this register now button. It's the first thing that shows up on the front page, and then I want to do an advanced search for spring. So here's fall, extended winter, spring. I can just pick advanced search, pick the spring term, pick the subject I'm looking for. So I'm looking for math, and my course number for Calc 1 is 181. And so then it will bring up all of the Calc 1 classes that are happening. Now, Rockville's teachers aren't in there yet. Tacoma Park is. Germantown is. So depending on where you're taking the class, and distance learning is as well. So if you're doing an online, if you want to do the class online, right? Maybe you don't want to go back to campus yet. Yes, it's view only right now. I think next Monday it's priority registration, and the following Monday is anyone can register. So if you have 30 credits or more, and please double check on that for me. I don't know that answer for sure. Double check for me that you can't register right now. But you see there's some classes that are Monday, Tuesday, Wednesday, Thursday. Some classes 3 days a week, some classes 2 days a week, and then of course the worst one is the online. So, but you're going to pick, like for me, like I said, I was picking a class based on when I was working and when I was free. And so you're going to be prepared for this. If you get an A or a B in this pre-calc class, you're prepared for this with anybody. Even the most demanding teachers, which I would say are probably Sharon, Dr. Haig, and Dr. Terrain. At least that's what's on here right now. I don't know John Byers, but that's a DL class. I don't know Pahlavi either. I know Robert Kuhar, unfortunately. So there's lots of options. And again, we're planning on being face to face, right? We're planning on being face to face. So, you're picking your whole schedule based on that you'll be on campus. Will it stay that way? I don't know. There was just a school in Fairfax, a high school, that went back to remote completely. So I can't guarantee anything.
Wait, so distance learning is just asynchronous, right?
Exactly. It's no lectures. It's you read the book, you watch the canned videos, and then maybe you go to office hours and talk to the professor that's grading everything.
Thank you.
It's like a glorified independent study. It sucks to me. I hate it. I don't do well with that. I need to be able to interact and see things live and ask questions, and I want the teacher to be in charge of like these online classes. It's like the tests are canned. Everything is just the teacher doesn't do anything. It's stupid.
We had that at LSU online, especially where we just like didn't have anything. And half of my teachers wouldn't even like post lecture slides or anything. They'd just be like, "Oh, read this chapter in the book," and then write an entire paper on it. And I'm like, "Great, thanks. That's helpful."
That's it. It sucks. I mean, I think it might work better for a class where you just have to read anyway. Like maybe it's a World Civ class or something. I don't know. I also don't like typing in conversation, like they all have you do these stupid chat or what do they call them? Some kind of rooms where you're in there talking, answering questions and all of that. I hate it. But don't listen to me. I am teaching one next semester. But it's not calculus. I don't think calculus should be done that way, but anyway, so that's there. Let me get back to the homework questions. Oh, I recorded all of that. I probably shouldn't have said I hated it. I think it's the greatest thing ever invented. All right, Ben asked for this particular problem. It says list the potential zeros. Now, I'm not going to ask you a question this simple. One, because it's too simple. But I will ask you at times, when you do a problem with potential rational zeros, it would be nice if you listed it and showed me that your actual zeros were in the list of rational zeros. So this particular function f of x is 11x to the fourth minus 2x cubed plus x squared minus x plus 1. And we know our possible rational roots, pos-rat roots, come from the plus and minus factors of the constant over the factors of the leading coefficient. Done. That's the theorem. So you can see here that I've got possibly plus or minus 1 or plus or minus 1/11th. But what are you going to do? You're going to graph this function and look and see where the possible rational roots are. If 1 is a root and it's not, then I'm just going to start to do synthetic division with 1, right? And so this is kind of leaning at the question from Wilder. If we list a bunch of possible rational roots, right, and you go to graph it, and it's not clear which one it is, then it could be one of your rational roots. So the one that Wilder sent me was f of x is 13x cubed minus x squared plus 13x minus 1. Now that one I can already see factors, and I don't have to do anything with the calculator, but with the so on this one it's saying it's saying that, what are my possible rational roots here? Again, rat roots, right? And it's plus or minus 1 over 1 or 13. So again, plus or minus 1 or plus or minus 1 over 13. And it looks like they're telling you that so I want to look at the curve, right? That's what I'm saying to you. I want to look at the curve. I want to look at the curve. And so I'm cheating a little bit, right? I'm saying I'm going to just use the calculator to tell me what's true and then verify using the algebra that I know how to do from this class. So I'm graphing that y equals 13x cubed minus x squared plus 13x minus 1. Oops. Plus 13x minus 1. And when I look at this, I definitely see it's not 1. It's not plus or minus 1. So my only choice is 1 over 13, right? Wilder, are you seeing that? Benjamin,
Yeah.
yes, you with me here? Benjamin? Benjamin Ellsberg, yes? You with me?
Yeah.
Okay, so I think it could be 1 over 13. It's my only hope. It doesn't have to be. It could be an irrational root, right? Usually the irrational roots come in pairs because of that quadratic formula piece. But let's see. So 13 minus 1, 13 minus 1, right? Do I have that right? Yes. So bring down to 13, multiply, I get a 1, I get a 0, multiply, I get a 0, I add, I get a 13, oh, I get a 13, yep, multiply, I get a 1, and then I get a 0, so it worked. So again, after you factor and find your rational roots, you could show me that those rational roots show up in your list of possible rational roots. Or if you go look at the function, you go look at the graph and you can't see a clear root, then look at your rational roots and then pick which one you think might work. Wilder, does that clear that all up?
Yeah. Thank you.
Yeah, so use the calculator, right? Even next semester, even in Calc 2, use your calculators to verify your calculus and vice versa. Use the calculus to verify the calculator, and you know, it works both ways. Nice. Good questions. Isaiah sent me one. Nice. Cool. So yeah, I like this one for your first test, for your test 2. I've got two linear functions, f of x equals 4x minus 1, and g of x equals negative 2x plus 5. And of course you're going to graph them, right? You're going to graph them. So I'm going to just graph them quickly by hand, right? I know I got a minus 1 here, and then I should go up 4, 1, 2, 3, 4, and over 1. So here's my f of x. G of x goes through 5 and then down 2 over 1. So g of x is here. And I know they cross at 1, 3. Of course, I could find where they cross, and I would expect you to show me where they cross using algebra, right? F of x equals g of x. Isaiah, this okay?
Yeah.
When 4x minus 1 equals negative 2x plus 5, so when 6x equals 6, when x equals 1, and then find f of 1, that's 4 times 1 minus 1, that's 3. So there it is. They meet at 1, 3, right? So So it gives me a whole bunch of things to solve, and I don't mind. I'll just do the whole thing. So question A says solve f of x equals 0, right? So that is what? 4x minus 1 equals 0, or 4x equals 1, or x equals 1/4. B, when is f of x greater than 0? So it's asking me when is that black line above ground, right? And it's always asking me for subdomains. So I know the domain of f is all numbers, but what's the subdomain? When is f above ground, right? And that's when x belongs to 1/4 to infinity. C, we already answered. When does f of x equal g of x? When x equals 1, or at the point 1, 3. It's not asking that, but I think it will ask it later. D, when is f of x less than or equal to g of x? So when is f of x below or hitting g of x? And again, I'm asking for subdomain, right? So f of x is less than or equal to g of x. And that's what from minus, when x belongs to minus infinity up to 1 inclusive, right? Because we already found out where they cross, right? Isaiah, you with me?
Yeah, I'm with you.
And so am I assuming that, I mean, it looks like you got everything right here, but is it the graphing one?
I was looking at my notes and somehow I did it wrong on my notes, but ended up getting it right on Math Excel. So I just wanted to go over it again so I could rewrite it down the right way.
Yep. And so I guess I would expect to see you graph it, right? Oops, sorry. I would expect to see you graph it, find out where they're equal, and then that's pretty much all you have to do. Everything else is, right? Everything else is from those graphs.
Okay, thanks.
Yep. Nice. Take a look at the video I did this morning if you want to look at a rational inequality. I think that's important to do. That's probably the toughest question on the test. Make sure you can do a difference quotient from test 1. Make sure you can complete the square, right? So everybody has their questions answered. Nice. I'm trying to get Math Excel to give you all the same questions, but I'm having a hard time. I still got 2 more days to figure it out. Yes, so Wilder asked, is there the questions from the first test will be part of the 10? Yes. So like a question in 3.3 is on quadratics, so right, 2 birds, 1 stone. Question in 3.1 is linear. It's like, I don't know. I don't know if I'm going to waste any time on that. But definitely come up with a polynomial, factor a polynomial using synthetic and the depressed equation, all of that. And then what was chapter, then graphing a rational, and then a rational inequality. So among all of that, those are pretty much the main problems. But if you can do that test 2 study guide, you can do everything on the test easily. And again, give me more than what Math Excel is asking. Math Excel is kind of dumb, right? When I say graph a rational function, I'm expecting all the asymptotes, all the points you can give me, short run behavior, long run behavior, the whole thing, everything I've been doing. Okay. Difference quotient. When we do the difference quotient this time, will you please test it like I did every time I made one? Right. So if I ask you to find me a difference quotient, verify that the difference quotient is true. Right. Go to the graph, pick 2 points on the graph, calculate the slope the way you did in 8th grade, and then redo it using the difference quotient and see if you get the same result. Nice. So let's see. So we looked at the schedule for spring. We talked about getting ready for this test and doing everything. How many students are here? 3, 6, 9, 13, 17. Missing 4 students. What the heck? Remember my goal for the beginning at the beginning of the year? I wanted everyone to pass. I have to change. I want everybody who's still here to pass. I can't get everybody to pass if they don't show up. So if you're gonna stick it out, I want you to pass, right? I'm supposed to be one of the chosen one, like Neo in the Matrix. That I'm gonna somehow fix the DFW rate in pre-calculus. This is what they've asked me to work on, but I can only do so much. You have to do your share as well. I mean, I can explain this stuff over and over as simple as I can to get anybody to understand it, but you still have to practice. So it's okay. I never asked to be Neo anyway. I don't know if he did either. Okay, Jamal just got here, and Manish, nice. Thank you. Now I'm only missing 3, 6, 9, 12, 15, 18. Now I'm only missing 3 students. Not bad. It's better. All right, we're starting chapter 5 today, and I don't think this will hurt you too much. I don't think anything I do today will really hurt you too much at all. We're kind of going through a checklist of functions and properties of functions to get you ready for Calc 1. And so we've already done sequences and series were for something else, okay? And you'll see them happen again. But linear functions, quadratic functions, which of course are both polynomials and polynomial functions, rational functions, and now we're going to be talking about composition of functions and inverse functions. So today we're going to talk about both of those, composition of functions and then inverse functions. Inverse functions is the big deal. That's really important to us. So inverse functions. And then we're going to be doing exponential functions and log functions here in this exponential and logarithmic functions. So that's chapter 5. Inverse functions, exponential functions, logarithmic functions. Those are the big pieces here that are happening all through calculus. And then we get into 3 chapters of trig. 3 chapters of trig. Oh, by the way, how is your trig class going? Who's taking 098 right now? How's it going?
It's good.
I am, yeah, it's going well.
Nice. And you're almost done, I'm assuming.
Yeah.
Did you get to inverse trigs yet?
Yeah.
Nice. So when I go through chapter 6 with you all, I'm going to go pretty quick because I'm assuming you took the 098 or you tested out of the 098, right? I guess it's possible for some of you to be taking 098 in the second term. Is that anybody here? In the second half of the fall semester. Anybody taking 098 in the second half of the fall semester? What's nice about it is if you pass 165, we don't care if you failed 098. So if you pass 165, you get into the calc class, and then we just pretend that the 098 never happened. And since it's a 0 level class, it doesn't transfer anyway, so it will never, it'll never be sent to another school. All right, let's talk about composition of functions. Now, speaking of compositions, I don't know if you heard this, the news today, that the Beethoven, they had found out that Beethoven was buried with all of these pieces of music, compositions that he made that no one had ever heard. Did you hear this on I think it was CBS News this morning. And so they dug up his grave, right, to get all these papers that he had written, music, and he's sitting there erasing. And they asked him, Beethoven, what are you doing? He says, I'm decomposing. All right, here we go. 5-1. Composition of functions. I'm assuming that you're gonna take up the entire Wednesday with questions. If you don't, I'll be pretty damn upset. But if you don't, I'll finish what I don't finish here today, right? For sure, we'll be able to finish 5.1 and 5.2 in the next two classes. But I mean, last time, the morning class asked questions to take up the whole session, and so then I tried to get you all to do the same thing. So hopefully you'll do that. Please send me the questions ahead of time. Okay. Yes, sorry, I'll record the class Thursday, and I'm recording now. And I did record this morning, because I did a couple of review problems with them that you all didn't ask. So it'd be good to watch that as well. So composition of functions. So f composed of g of x. I don't like that notation. It looks like fog, right? But that is looks like a multiply circle, but it's definitely hollow. I don't like that as much as I like f of g of x. And so you can see that I'm actually putting the function g of x into the function f of x. Is a composition of functions. The book will use this first notation here in green. I never do. I always use this one. In blue. I always use this one. It just makes a lot more sense to me that I'm putting the function g inside of the function f, right? And that's what it means.
Which one will MathXL use?
The green. They use the green.
Okay.
But just know it means what I'm writing, right? It means actually put the function g inside of the function f, right? So this is the inside, and this is the outside. And that's a big part in Calc 1 when we do something called the chain rule. You should be able to identify the exterior function and the interior function. Chain rule's a beast in Calc 1. That's probably the most difficult thing. So you make sure when you get to the chain rule, you reach out for help. You go to your whatever organic chemistry tutor guy or whoever you're using on YouTube and really get that chain rule down as soon as you possibly can. So let's look at a quick. Now we've done this already, right? We've seen this composition of functions before already this semester. Jamal?
I was gonna say, I think chapter 2.
Yeah. And what did we do? Do you remember?
No, not necessarily, but I remember it was like somewhere in chapter 2 that
Yep.
we did it.
Yep. Ryan, what do you think?
Oh, I don't. But I just know that we're gonna put like substitute an x. We're gonna put g of x.
Okay. So when did we put something into f of x before? When did we put something abstract into f of x? Not a number. When did we put something abstract into f of x?
When we did x plus h.
Exactly. The difference quotient, right? Which was chapter 2. You were right. So we've done this already. We put a function inside of a function already, right? So this is really nothing new. But let's take a look at a couple of quick examples real quick, right? So let's say f of x is x squared minus x minus 1, and g of x is x minus 3. I want to find, and I do this all the time, I want to find the composition h, because I don't like to write f of g of x every time. I want to find h of x, which is f of g of x. And how I do that is I'm going to write my outside function with empty parens and my inside function right in another color inside. Everybody with me? Outside function with empty parens, evaluate at the inside function. So here I get x squared minus 6x plus 9 minus x plus 3 minus 1. And I get x squared minus 7x plus 11. And there's my composition. Now we have to talk about, yes, Gloria, go ahead.
So we basically plug in g of x to x. Is
Exactly. And so you're first replacing with empty parens for every x. Yep. And so we're going to be thinking about domain here, but in this particular case, both functions are continuous. And when I compose continuous functions, I get a continuous function. So this one isn't horrible to think about the domain here, right? Our domain here for G was everything, for F was everything. The weird thing is I have to think of the range of G to get the domain of F. And I'll talk about that later. But I want to take a look at something. So for example, let's find G of 5. What do I get when I plug in G of 5? I get 5 minus 3, that's 2, right? So I start with my input as far inside as I can, right? So now my output is 2, but that's what I'm going to put into F. And what do I get? 2 squared minus 2 minus 1. So 4 minus 3 is 1. So inside of my composition now, I'm going to put in a 5, and I should get out a 1. So let's find that h of 5. I get 5 squared minus 7 times 5 plus 11. I get 25 minus 35 plus 11. Negative 10 plus 11, I get out to 1. Check. So I'm taking a kind of a function within a function and creating a brand new machine with it, right? If you kind of think of, I've got this machine that's going to dig dirt and get the gold, and then another machine that's going to take the gold and melt it down. Now all of a sudden I have a machine that digs dirt and melts down the gold, right? So it's taking two things happening in a cycle within each other and creating a brand new machine out of it. Let's do another composition, okay? Let's see. Let's do f of x is x minus 1 over x plus 3, and g of x is x plus 2 over x minus 5. So let's do this composition. Now this one's a little weird. The domain of G is everything but 5, right? And the domain of F is everything but -3. So got to be careful here. I can't have the input of G be 5 or the output of G be -3, right? So G of 5 does not exist, right? And G of x equal 3, -3, should not exist. Right? Because again, I'm talking about h of x is f composed of g of x. Is that making sense? Right? Because you can see g is inside. So if I got a value of g that gave me a -3 and then I plug that into f, I'm in trouble, right? So this particular go ahead.
Does that only apply to the bottom or also the top?
The interior.
Okay.
Yeah. Oh, I see what you're saying. Because they're fractions, remember our domain is you can't divide by 0. We don't care about anything else. Yeah. So our domain of h is x not equal to 5. And then when is g equal to 3? Don't tell me. -3, right? And x does not equal 13/4. So those are the two values are not in my domain. It's a little bit strange. But I'll talk about that again in a little bit. Again, I have to look at the domain of G, and I have to look at the domain of F, and then I have to make sure the output of G is all in the domain of F, because G is the interior function now. All right, so what do we get here? H of x is x minus 1 over x plus 3. There's my function f. Do you see the function f as empty parens? Do you see the function f as empty parens? And I'm putting in there x plus 2 over x minus 5. So I put in the function g into the x's of f. And I want to do that same thing I did when I was doing my difference quotient. I want to try and cancel my interior denominators. So I take a look at the LCD or LCM or just common denominator, common multiple of those interior denominators, which is x minus 5, and multiply top and bottom by x minus 5. Everybody with me here? Everyone okay? Nice, Brian, thanks. Nice, Jamal. Brian, thank you. Elise. Elmer, yes? Kind of, yep. Nice. Isaiah, nice. Vaughn, nice. So I keep going. I want to get a nice single factored numerator and denominator. So I get x plus 2 minus x plus 5 all over x plus 2 plus 3x minus 15. So it looks like I get 7 over 4x minus 13. What do you think? Is it a coincidence? Is it a coincidence that I look at the domain of H? What number do you notice is really bad for me?
13/4.
13 over 4, and I knew that before, but I also can't put in 5. right? I cannot put in 5. I can put in 5 here, right? I can put in 5 to h, right? H of 5 is what? 7 over 20 minus 13, 7 over 7, which is 1, by the way. And what's the issue with that in G? Look at 1 compared to G. What's the problem?
The function, I was going to say the first function has 1 in the numerator, but that doesn't matter.
Nope, it's something else about that 1. It's something else about that 1 compared to G. Who can see it? Who's got the genius brain on?
And I need my coffee, Professor.
I don't blame you. I already had mine. Who's got it? Anybody? Who's the genius in here? I know somebody is. Elise? She's like, no, I'm not. I am a genius, but I'm not going to answer. It's my prerogative.
I need my second cup of coffee.
Oh, you need your second cup, okay. Who sees it?
You said 1 compared to G.
Yes. What is 1 compared to G? The horizontal asymptote. If I graph G, there's a vertical asymptote at 5. There's a horizontal asymptote at 1, right? And bigger than 5, it looks like 1, it's doing this. So you can see G has never got a height of 1.
Oh, so it's not, it's never going to touch 1.
Exactly. So it can't happen for G, right? There's no place where that particular thing happens. So I don't know. It's kind of cool. So we have to be able to do a couple of things. We have to be able to do. We have to be able to compose functions like we just did. What happened? Something froze. It just froze. Hold on. Crash. Oh, by the way, next Tuesday there are no classes. You're doing something called Advising Day. So that would be a day that you should take advantage of, going to check with your program advisor, making sure you're on the right track, that type of thing. Anyway, my checklist here. I want to be able to compose functions like we just did. Check them like I did, right? By doing the inputs into the composition, inputs to the original functions. Evaluate using tables, right? I want to be able to, what else? Don't tell me. Oh yeah, find domains. So let's take a look at one with a table, because I think for some students those are kind of weird, kind of tricky. Let me just open my book here. Oh, and then the inside-outside look. That inside-outside problem is going to come more into play in calculus than here. You're not going to see inside-outside problems in our homework. But I want to look at a couple today anyway. So let's look at a table problem first. These are they're very simple, but for some students it gets a little bit confusing. So I'm looking at number 9 here. Let me just move it to my other page here. So number 9, there's a whole bunch of parts, but you can see here part A, C, and E. I'm composing F composed of G of 1. Then G composed of F of -1, then G composed of itself of -2. Self-composition is a thing that happens in nature quite a bit. It's how things grow. It's how fractals are created, that kind of thing. So, but let's do the first problem. F composed of G of 1. I think you can see my mouse. Can you see my mouse right now hovering over the problem? F composed of G of 1. Can you see that? Yes, okay. So my original input of 1 of the function g. So I've got to find when x is 1 and go down to the value of g, and I get g of 1 is 0. Everybody with me there?
Yep.
Nice. So now I have, go ahead. Yes? Now I have an output of g of 0, so that means I'm going to pick x is 0 and put that into f, and I get a result of -1. So it's like following a stupid treasure hunt, whatever they do when they, remember when you were a freshman and they made you go find the counselor's office. Now go take a picture of where the cafeteria is. Duh. So it's that kind of thing, but you just got to think a little bit. Let's do part E. G composed of G of -2. My original input is -2. Find a -2 for inputs. I got it. Go down to the function g. What's my output? Good. 3. I found the library. Now take 3 and put that back into the function g again. So x is now 3, and go down to g. What do you get? 8. So g composed of g of -2 is 8. Does that make sense? Everyone okay there?
Yes.
So those are pretty easy. They do the same thing with a graph. It's just looking at the heights for outputs and x's for inputs and heights for outputs. Same thing. Does anyone want to do one of those? Anybody want to pick one that we can do? Number 11. Anything?
Let's do C.
Nice. So F composed of G of -1. So my original input is -1. So I want to find -1 of G. So -1 of G is the height. I'm sorry, -1 of G is the height 3, right? So X is -1, and what's my height for G? It's 3. So now it's saying, okay, go to an input of 3, 1, 2, 3, and go to F, right? And so what is that height?
That's -1.
-1. There it is. It's that simple. Just got to think a little bit. You got to be patient, right? You can't have the TV on and the radio on and family yelling at you and be able to do this stuff. Put the headphones on and say, shut up, I'll be down for dinner later, or something. You know, you don't have to say shut up. But. So problems 13 to 22 is a bunch of domain problems. I think the one problem that might be interesting here would be 21. So let's see if we can do 21 and work it the way we worked it before. So I have an f of x is 3. Oh, no, it's not asking me for domain here. It's the next page, sorry. Here we go. State the domain of these compositions. I think 31 is interesting. 31 could be pretty interesting, so let's do 31. f of x is x over x minus 1. And g of x was what, 4 over x, is that right? Negative 4 over x, that's fine. So we want to find the composition H of f composed of g, right? And we want to find the domain. So first of all, what's the domain of g?
Everything except 0.
Nice. What's the domain of f?
Everything except 1.
Nice. So I want a range of g so that x does not, so y does not equal 1. Because remember, my output of g is going to go into the input of f. So the key here is, right, no y values of 1 for g. And it's going to be this way every time. I have to think of the domain of g, the domain of f, and then the range of g. And I have to make sure the range of g jives with my domain of f. So I want to make sure that negative 4 over x does not equal 1, which means x should not equal negative 4. So my domain of h is going to be x is not 0 and x is not negative 4. Those are my two issues I have. All right, let's find the composition. We're racing right now, right? How we doing? Anybody get there? Anybody get to the green? Anybody get to the green circle?
Error.
Yeah.
Yep, and then we just want to simplify, right? You can factor out a negative from everything and cancel it. All right, let's find h of 2. Shouldn't be a problem, right? H of 2 should not be a problem, right? Because it's in my domain, right? The only thing I can't find h of is h of 0 or h of negative 4, and I'll try both of those. So h of 2 is what? 4 over 2 plus 4? So 4 over 6, or 2/3. Okay? Good, let's find g of 2. It's negative 4 over 2, it's negative 2. And let's find f of negative 2. That's negative 2 over negative 2 minus 1. That's negative 2 over negative 3. That's 2/3. No, we're not surprised, right, that my individual machines gave me the same result as the composition. Let's look at our trouble spots, right? H of 0 is no problem, right? That's 4 over 0 plus 4, which is 1. I had made the mistake before of saying this is the horizontal asymptote of G. It's the horizontal asymptote of F, not G. But what happens when I go to G of 0? I get minus 4 over 0, and it can't happen, right? So I'm in trouble. It blows up. What's H of minus 4? Well, it blows up, right? I get 4 over minus 4 plus 4, that's 4 over 0. That's no good, right? G of negative 4 is no problem, right? That's negative 4 over negative 4, that's 1. But F of 1 is what? Don't tell me. 1 over 1 minus 1, that's no good. So those domain issues are going to show up either in my brand new machine or one of my composed machines. It's all right. Don't worry. Nice. Let's play the inside-outside rule. That's the only thing we have left. Right? We talked about domain. We talked about composition of functions. We talked about evaluating compositions, whether using a chart or a graph or just some number free to pick for me in the domain, or even pick something that's not in the domain and show it to trouble, right? But let's look at this inside-outside rule. Inside-outside rule. I guess we could do 49, square root of x squared plus 1. Right? So this is inside-outside game. Someone asked me the other day if I had an innie or an Audi, and I said, no, I don't have an Audi. I have a Mercedes-Benz. I don't actually have a Ford. So here's my function. Can you tell me the outside function? Can you tell me the f of x? What is it?
Square.
Square. What'd you say? X squared?
Huh?
Outside. Look at the outside. Look at the house.
That's the square.
Square root, right?
Mm-hmm.
You see the outer piece, like the roof of the house is square root, right? What about the inside? Anybody got the inside here? This is the easy version. What did you put into the house?
X squared plus 1.
Nice. Good. I'm going to change my outside for it, right? So this is my outside, this is my inside. Let me see if I change my outside, can someone tell me the inside? I'm going to take the outside as x square root of x plus 1. Who can tell me the inside now?
X plus 1.
X plus, say it again?
X plus 1.
X plus 1. So if I put in x plus 1 into f, right, I'd get x plus 2 inside, right?
Is it x squared?
X squared. So now, remember, where am I putting that g of x, right? H of x is f composed of g of x. It's square root of empty parens plus 1, and what am I putting into the empty parens to get my composition, the x squared? So this is something that's very useful for you when you're doing the chain rule in Calc 1, right, next semester. Let's try one more like this, and then we can be close to done. Inside-outside rule. Let's see, f composed of g is x over x plus 1. What's the inside? What's the outside? This is a little tricky. It's kind of boring to say that the outside, right? It's really boring to say that the outside is x over x plus 1 and the inside is x. It's not much of a composition at all, right? So we have to get a little bit creative with it. Go ahead, Ryan.
No, it's just, yeah, you put X.
Yeah, this one's boring. It's not. It's boring. It's like playing tic-tac-toe. We know, right? We know you can never win in tic-tac-toe. Anybody got one? Well, what if I tell you g of x is x plus 1? How about now? What do you got for me?
It will be X plus 1 on X plus 2.
Almost. I'm trying to find the function, right? I'm trying to find before the composition, not after the composition.
It will be X.
It's x minus 1 over x. Right? So now look at that function, that composition. It's parenthesis minus 1 over parenthesis. And what am I putting in? X plus 1. What happens to the ones upstairs? The ones upstairs cancel, right? So do you see I get this? I get my composition now. So it's not easy to do that. It takes some practice, okay? Usually you won't have to deconstruct the composition. You'll just be able to recognize the inside. If you can recognize the inside and the outside, like in this case, right? If you can recognize the inside and the outside, pretty simple. And that's the, this is tricky compared to what you'll have to do in Calc 1. Nice. So for homework in the book, I like definitely 23 to 38, and I like the ones with fractions. If you want to take a quick photo of any of those right now, so you don't have to try and open the book. And then of course you can double check yourself using Symbolab, Photomath. What else? What else did we use in 50 to cheat? Wolfram Alpha. Wolfram Alpha is what I used to get through grad school. Symbolab is really powerful. Photomath, you just take a photo of it and it will do the problem for you with your phone.
Professor, what are you talking about? I don't cheat.
No, I'm saying, you want to know if you got these right. You want to know if you get them right.
Oh, right.
Yeah,
My bad.
Right. I was all set to cheat on my driver's test the other day, right? I was going to get my license, and the instructor said, "Go ahead and back up." And I just sat there. I didn't go anywhere. He said, "Go ahead and back up." I mean, I knew I was going to pass because I knew how to cheat, but he was asking me to do something that's impossible to do. You can't go ahead and back up.
Not gonna lie, Professor, that one flew over my head.
Go ahead and back up. Go ahead and back up. Okay, I'm done for today. I'll see you Wednesday. Get some questions to me, please, before 12 o'clock on Wednesday. All right?
I have a question.
Professor, thank you.
Sure, you got it. Go ahead. Elise?
Can we, on Wednesday, can we review horizontal asymptotes versus oblique asymptotes?
Yes, absolutely. And if you can find one that you want me to do, that's even better.
Okay.
Yep.
Thank you.
Yep.
Thank you, Professor.
You got it.
Thank you, Professor.
You got it.
Thank you.
Matthew, okay?
Yeah, I'm sorry. My Wi-Fi just been really spotty, so it's kind of